Dear students, welcome to RV Tutorials. In this video, I am going to solve the exercise number 1.1 problems from the chapter Number Systems. Dear students, before going to solve the exercise problems, we know the few things about numbers. Dear students, we have already studied in previous classes about numbers, that is natural numbers. Dear students, numbers from 1 to infinity. Counting numbers from 1 to infinity, the group of numbers we can call it as natural numbers. This natural numbers is denoted by n alphabet, and second one is whole numbers. Dear students, counting numbers from 0 to infinity, the group of numbers we can call it as whole numbers. These whole numbers are denoted by W alphabet, and third one is integers. Dear students, including whole numbers 0, 1, 2, 3, dash, 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 up to infinity, and also -1, -2, -3, dash, 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 up to infinity. These group of numbers we can call it as integers. Integers are denoted by Z alphabet. And rational numbers. Dear students, rational numbers are those numbers. It includes integers, fractions, terminating and repeating decimals. Dear students, rational numbers we can express in the form of P by Q. That is, we can express the number in the form of numerator and denominator. These numbers we can call it as rational numbers. 0, 1, 2, 3 up to infinity, and -1, -2, -3 up to infinity. Positive integers and negative integers, and also for example 1 by 4, 0.5, for example 1 by 7, 6.66 up to infinity. Like this, we can express in the form of P by Q the numbers we can call it as rational numbers. And irrational numbers. Dear students, non-terminating and non-repeating decimals are irrational numbers. We can't express in the form of P by Q. That is, we can't express numerator and denominator. Those numbers we can call it as irrational numbers. For example, pi, √2, √3, dash, 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 dash. These group of numbers we can call it as irrational numbers. Dear students, real numbers. Students, real numbers includes natural numbers, whole numbers, integers, and rational numbers and irrational numbers. These group of numbers we can call it as real numbers. Dear students, knowing these things we can solve the exercise problems. Dear students, in number system exercise 1.1, first problem, is 0 a rational number? Can you write it in the form P by Q, where P and Q are integers and Q is not equal to 0? Dear students, 0 is a rational number. We can express in the form of P by Q. That is, we can express 0 in the form of numerator and denominator. That's why you can write the solution. Yes, 0 is a rational number. It can be written in the form of P by Q. For example, 0 by 1, 0 by 5, 0 by 8 are rational numbers, where P and Q are integers and Q is not equal to 0. Second one, find 6 rational numbers between 3 and 4. Dear students, we can get the 6 rational numbers between 3 and 4. Solution: to get 6 rational numbers between 3 and 4, the denominator must be 6 plus 1. That is, dear students, they ask in question 6 rational numbers between 3 and 4. That's why I am adding 6 plus 1. They ask 6 rational numbers. That's why I am adding 1. That is 6 plus 1. It becomes a 7. That's why I am multiplying both numerator and denominator by 7 to the number 3 and 4. Here 3 by 1 into 7 by 7 and also 4 by 1 into 7 by 7. That's why I am multiplying numerator to numerator and denominator to denominator. 7 3 ja 21 divided by 7 1 ja 7. Here 7 4 ja 28, 7 1 ja 7. Between these two numbers we can write the 6 numbers. After 21 by 7, that is 22 divided by 7, 23 divided by 7, 24 divided by 7, 25 divided by 7, 26 divided by 7, 27 divided by 7. These 6 numbers are rational numbers between 3 and 4. That's why the rational numbers between 3 and 4 are 22 divided by 7, 23 divided by 7, 24 by 7, 25 by 7, 26 by 7, 27 by 7. Third question, find 5 rational numbers between 3 by 5 and 4 by 5. Dear students, they ask 5 rational numbers between 3 by 5 and 4 by 5. That's why solution, to get 5 rational numbers between 3 by 5 and 4 by 5, the denominator must be 5 plus 1 equal to 6. Dear students, they ask 5 rational numbers, that's why I am adding 5 to 1, that is 5 plus 1 equal to 6. I am multiplying this 6 both numerator and denominator to the number 3 by 5 and 4 by 5. That's why 3 by 5, 3 by 5 into, I am multiplying this 6 to numerator and denominator 6 by 6 and also 4 by 5. I am multiplying this 6 by numerator and denominator 6 by 6. That's why 6 3 ja 18, 6 5 ja 30, 6 4 ja 24, 6 5 ja 30. Between these two numbers I am writing few rational numbers, that is after 18 by 13, that is 19 by 30, 20 by 30, 21 by 30, 22 by 30, 23 by 30. Dear students, the rational numbers between 3 by 5 and 4 by 5 are 19 by 30, 20 by 30, 21 by 30, 22 by 30, 23 by 30. Question number 4. State whether the following statements are true or false. Give reasons for your answers. There are 3 statements are there. First one, every natural number is a whole number. Second one, every integer is a whole number. Third one is, every rational number is a whole number. Dear students, first statement is, every natural number is a whole number. Every natural number is a whole number. Whole number includes natural numbers. That's why this statement is true. You can write, dear students, this statement is true, as whole number is the collection of natural numbers and 0. Dear students, second statement, every integer is a whole number. Dear students, this integer includes 0 and also positive integers and also negative integers, but whole numbers includes positive integers and also 0 but not includes negative integers. That's why this statement is false. You can write, this statement is false because negative integers are not whole numbers. Dear students, third statement, every rational number is a whole number. Dear students, every rational number is a whole number. This statement is false, dear students, because this whole number not includes decimals and fractions like 3 by 5 and 2 by 3. That's why this statement is false. You can write, this statement is false. Rational numbers like 3 by 5, 2 by 3, etc. are not the whole numbers. Dear students, if you like this video, like, share and subscribe this channel. Thanks for watching.